section that's in the textbook. The approach that's in here, that's why it says 10-point problems. It's there's 4 sections in that chapter, but this involves solving problems that are throughout the whole chapter, right? They're in each of the sections, but we want to focus on some of the problem solving right at the end here, even though you've been working on a little bit throughout. Basically, the two things, or the thing involved here, real world situations and using equations to solve them, okay? So you have to be able to solve problems using equations, okay? Using 1- and 2-step equations. It's not just solving problems. Some of the problems that you work with, you're going to be able to solve without using equations. You just can work backwards in your head. But the idea is you have to be able to show here that you are able to write an equation, solve it, use that to solve the problem. As a starting point, the first thing to be able to do is to translate something that's in words, or translate a situation to mathematical symbols. So that's what this first thing is about here. Words are important here. You have to read the words carefully. You have to kind of translate the whole statement and not just one word at a time. All of these things involve an unknown number. Here's some number. How can you write with symbols something for just a number? How do you represent it in math, algebraically? What do we use to represent unknown numbers? X or N or something like that. If you're using N for a number, how do you represent the quantity that's 7 more than that number? What's 7 more than this number? We don't know what N is, but we can still write what 7 more than that is. I take that number and do what to it? Well, timesing by 7 would be 7 times. It's not 7 times as much as a number, it's just 7 more than it. Like if you have the number 10, what's 7 more than that? You know this. What's 7 more than 10? 17, right? What did you do from this to get to this? Add 7. So you can just add 7 to n. Even though you don't know what the number is, you can write an expression, and that's the key here. You can write an expression and then work with it. 3 less than a number. Start with what you're going to use for the number. Maybe you use x. It doesn't matter what you use. If x is the number, what's 3 less than that number? What's 3 less than 10? 7, right? What do you do to the 10 to get to the 7? Minus 3. So you do the same thing here, 3 minus 3, right? The problem is some people try to translate it one word at a time, and they say 3, and they say less than, and they say, how do you write less than? And they write less than, and then a number, and they put that. This is not how you translate that. You need to think about what it means, right? So it's not that. Okay? Don't try to translate it one piece at a time. Look at the whole statement and translate it. 1/3 of a temperature, how do you get 1/3 of something? If the temperature is T, how do you get 1/3 of that? Yeah, divide by 3, or really you could times it by 1/3. You could do either one, 1/3 times T or T divided by 3. 4 times as fast as S, S times 4, 4S. 5 less than triple a number. These ones start to have 2 operations involved here. 5 less than triple a number. It helps again to start working from wherever the number is here. Number, triple a number. How do you write triple a number? 3x maybe. 5 less than that. 5 less than that. How do you make something that's 5 less than that? Take away 5, right? So don't just start to do it one word at a time. Don't say 5 less than 3, and it's not that, okay? You're trying to write an expression for the entire thing. 9 more than half a number. Half a number. Divide by 2. 9 more than that. Plus 9. 4 times the sum of a number and 6. The sum of a number and 6. What does this word sum mean? The answer when you do what? When you add the 2 together. The sum of a number and 6, you got sum of a number and 6, you can just write as x plus 6, but now it says 4 times that much. If it's 4 times that sum, you need brackets here, and then times 4. Okay? 4 times this entire sum You need brackets around it. It's not right if you just put it like that. Okay? Twice the volume decreased by 5. Twice a volume V. 2 times V decreased by 5. Decreased by 5 means subtract 5. If you haven't already started it, at some point you're going to do this puzzle. Don't just do this and draw lines connecting them. It's best if you can try and actually write it first. 3 times a number, 3x. And then look for it. There's 3x, so this is number 3. It's best if you try and write it and then see if it matches here. You're going to get a lot more out of it than to just go this and connecting the lines. Second part of this section is about solving problems. These things are not all in the textbook. Some of these are in the textbook, but some of them aren't. The idea here is that you're solving it using an equation. Okay? So it's not just solving problems. I have news for you. These are pretty easy problems, and you can probably answer it without doing the equation part of it. You could probably give this to a grade 4, and they would just do it by kind of working backwards, a trial and error or something like that. But what you're learning in grade 8 is to use an equation here, using equations. If we started you with really difficult problems, then it's harder to see why it works. We start you with easy problems that you can even see what the answer is before you do it. Okay? So you're learning the method here. Here's the method. You're going to identify whatever's the unknown. You're going to write some kind of equation involving that unknown. You're going to solve your equation, and then you're going to use that to answer the problem. Okay? So identifying a variable in math, what you do is you pick the variable, and you usually write what's called a let statement. So you've got to read through this and figure out what's the unknown here. If you're looking at that, think about what the unknown is. An amount of money from a prize is shared equally among 4 people. What is the prize worth if each person gets 321? So some amount of money from a prize, or in other words, what's the prize worth? That's the unknown. Maybe you could do P for prize. You could say let P equal total prize or prize amount or something. If you open to this page, can you copy this down, please? So you have something to look back on, because you don't necessarily have something to look back on in the textbook for all of these. They're not all in the textbook. So that's that first step. Not very difficult, right? That's what's called a let statement. You're just introducing the variable. You're saying, like you're in charge here, you're saying let the variable P represent this. If you just start using variables without saying what they are, it's kind of sometimes hard to know what people are doing. Don't assume that people know what you do if you're starting using a variable. So that's kind of first step there. Second step is write some kind of equation. You have to try and translate what it says up here, not just one word at a time, but you have to think about the situation and what it's going to mean in terms of an equation. It says the amount of money, okay, this variable, that amount of money is shared equally amongst 4 people, and then that's equal to 321. So it says whatever the prize is shared. How do you share something equally amongst 4 people? What operation do you use? Yeah, divide by 4. So P divided by 4 gives us what result here? 321, right? That's your equation. Whatever the prize is, divided by 4 gives you 321. Okay, this says P divided by 4. Whatever the prize is, cut it in 4 pieces, and that each piece is 321. If you want to solve this equation, what do you do to solve that equation? What do you do to both sides? Because we're pretty good at it now. If it says P divided by 4 here, how do you undo that? What do you do to both sides? Well, times it by 4, right? Times 4 times 4. And you end up with just this on this side, P equals something, 1284, something like that. But you're not quite done then. You need to write some kind of an answer. It doesn't necessarily have to be a full sentence, but it's got to be something with words. You have to say something like each person, or not each person. What was our variable again? What was P?
prize, no.
Yeah, total prize is $1,284. So that's your 4-step process here. Okay? 4-step process. That's the process you're going to follow. You're going to do, first of all, you're going to identify your variable. There's identifying your variable. Second, you're going to write some kind of an equation. There's your equation. Third, you're going to solve the equation. Here's solving the equation over here. And fourth, you're going to write some kind of an answer. There's the answer. Okay? 4-step process. Not because this is difficult, again, just because you need to learn the process with simpler things and then move on to more difficult things. Okay? Each of the equations you write is going to be different. You have to decide, is it a 1-step equation? Is it a 2-step equation? This example is all 1-step equations. So your equation is only going to involve 1 step here. This is only going to be a 1-step equation. This is going to be a 1-step. There's 3 of them in there. There's going to be one involving division, one involving multiplication, and there might be one involving addition or subtraction. And then there's a show you know question, one single question here. You are going to need to try that on your own at some point. Actually, can you, if you have not already done so, well, let's leave it for a couple minutes and you can do those 2 after. I do want to show you the second one here, which is, I want to show you one example of each one here. This one is solving problems using equations where it's 2-step equations. Okay? This one is in the textbook if you want some further explanation later. Oops. If you want further explanation, it is in the textbook, page 382. Again, the idea is using an equation, not just saying, let me work backwards and figure it out. Okay? What you're learning again is how to use an equation, right? Using equations. So 4-step process. First step, identify what's unknown. So if you read through that thing, again, they're kind of silly questions at the start, but cow sleeps 7 hours a day. This is 1 less than twice as much as an elephant sleeps. How long does an elephant sleep? What's the unknown in the question? What's the unknown number? We know how long the cow sleeps. What don't we know? How long the elephant sleeps, right? So you should, now don't just do this. Don't just say, like you can pick a variable. You probably want to pick something that makes sense, right? If you're talking about elephants, maybe you could say E equal, don't just say E equal elephant. Okay, you got to write something a little more specific here. If you just say E equals elephant, it could be its weight, its height, its amount it sleeps, how much money it has, I don't know. What, put at least a couple words here, right? Hours that elephant sleeps or something. Okay, something like that to start with. Okay, so that's step 1. Step 2, write your equation. You have to try and translate the whole thing here. You have to try and read the situation. It's easiest if you start by thinking of a balance. Remember when we did this? I'm not going to make you start drawing them, but it's easiest if you think about a balance and what's on each side. Let's pretend that here's the cow over here is 7, right? Does the cow sleep the same as the elephant? No, it doesn't. So if the cow is 7, elephant's not 7. What does it say here you have to do to the amount that the elephant sleeps to get 7? It says this amount. So 7 is 1 less than twice. 1 less than twice. Let's highlight it. 1 less than twice the amount an elephant sleeps. That's like the thing we did before where you're translating a sentence. Okay? So it doesn't say that a cow is equal to an elephant. You don't just say E equals 7. What do you have to do to this to get it to be equal to 7? What operations do you have to do to that? 1 less than twice? 1 less than twice an elephant. So what do I do? How do I write that? 1 less than twice E? 2 times E minus 1. That's your equation right there. 2 times E minus 1 is 7. 2E minus 1 equals 7. That is the hardest part of the whole thing, is writing the equation. but that's the key for this whole thing, is being able to write the equation. Getting the answer is not the key here, right? This is kind of 1 out of 4, I guess, if you can solve the problem. This is the key, being able to write the equation. Once you write the equation, then it's fairly easy to solve it, right? Step 3, solve the equation. Once you get the equation, just solve it, right? 2e minus 1 equals 7. What do you do to both sides there to solve that? This gives you a good review of what you did before. What do you do? Add. So then what do we have? We have just a 2e over here. And you got 8. And then, yeah, what's the next step? Divide by 2 on both sides. And what are you left with? E equals 4, right? Now I know you could probably figure that out again just by saying, well, if it's 7, it's 1 less than twice as much, so it must be 8, 4. You can get this answer here. Elephant, sleeps 4 hours a day. Okay? And that's step 4, answering it, right? Okay, each of those 4 steps. Afterwards, you're going to try doing this one. But I want to do the last example with you here, which is this. 2 steps involving division. Kind of a hint here again. The equation you're going to get is a 2-step equation involving division. Again, this one's in the textbook as well if you want to look back at it later. You're going to follow your kind of 4-step process here again. Okay, we're going to read through this. Look what's unknown. The elevation of this place is 1 less than half that of Prince Rupert. At this point, we don't know either one of those, right? We don't know elevation of that place, and we don't know elevation of Prince Rupert. It does say the elevation of this place is 18 meters. What's the elevation of Prince Rupert? What is the unknown here? Elevation of what place? Prince Rupert, right? So we should say something like, now should we use E for elevation? Should we use E for elevation? Well, the problem is you're talking about elevation of 2 different places, so it probably makes more sense to pick something that just goes with Prince Rupert, right? P. I would say P or R, something like that. And again, don't just say P equals Prince Rupert, elevation. You can abbreviate it, of Prince Rupert. Prince Rupert's right on the coast of BC. Right, shows a little map here somewhere in the... Okay. That's step 1 already, right? Identified the variable. Writing your equation, try and translate it. Again, I think it's best to think about a balance. I am going to actually physically write the balance up here for you to think about. Here's the balance. Because I think some people just try to scribble down a bunch of symbols here. P times 2, blah, blah, blah. Think about the 2 cities. Does it say they're equal? P and R? Not P and R, sorry. What would... The other place, even though we know it, I'm going to put a Q here. Is that place equal to Prince Rupert? Does it say their elevations are equal? It does not say they're equal. It says this one. It says it's 1 less than half the elevation of Prince Rupert. How do we write 1 less than half of Prince Rupert? This symbol here, this is going to be like the equal sign in between the 2. If you're comparing those things, 1 less than half the elevation of Prince Rupert, how do you write 1 less than half? How do you write half of Prince Rupert? 2 different ways you could do it. Divide by 2, and then it says 1 less than that. How do you write 1 less than that? Minus 1. There's your equation right there. Start with the comparison, and then try and write it from that. So it says, but we do know what the Q is. What is the Q? It tells you that, right? Yeah, well, how much is it? 18, right? So 18 is Prince Rupert divided by 2 minus 1. That's your equation, right? Start by comparing the 2, but then one of the numbers you know, right? You could write it like this. P divided by 2 minus 1 equals 18 if you want. So then we got to, that was step 2. That's the hardest part. Step 3 is trying to solve the thing. if we're trying to solve the thing, think about what step you do first. Let's squish that over a bit. Here's our equation. P divided by 2 minus 1 equals 18. If you're going to solve this thing, what's a good first step there? 2 steps. Get rid of that number first. Plus 1, plus 1. You have left then just the P divided by 2, and you have 19. What's a good next step here? Yeah, times this. Times 2. Times 2. Right, this one involved division in the equation, so you're going to multiply it. Get rid of it. This leaves you with just Prince Rupert on that side, and 2 times 19 is 38. Okay, and then you can answer your equation. That was step 3, solving it. Step 4 is answer the problem. Prince Rupert is 38 meters in elevation. Okay, there's your answer. Now really we could have put in here a step 5. Do you want to add a step 5 to the thing? What might a good step 5 be if we were going to add a step 5 to our process? Well, no, even if you have that here when you're answering the question, that's part of step 4, but absolutely put the meter sign. What's that? We could have. We did do that. I was thinking more that once you get your answer, shouldn't you look back at the original thing and see if you're right? Can you check if you're right here? What would be a way of checking if this answer is right? How can we check if we're right? What if we went back to the original question and checked if it worked? Is 38 meters, does it work in this? If you think, if you reread the original thing, it says that this place in Nunavut is 1 less than half of Prince Rupert. You could do step 5 is check your answer if you want. If you take 38, it says 1 less than half of that. If you do half of that and you do 1 less than that, does that equal 19? Sorry, not 19, 18. Does that equal 18 like it should? This is 19 minus 1. Does that work? It works, right? You can check, right? 1 less than. You can reread the original question and check if you want to put a kind of a step 5 in there. In my experience, grade 8s don't like to check their answers on things. This question is in the textbook, sort of. Okay? This textbook is written for all of Western Canada. And so some of the other people who are involved, I was involved in this, but a lot of the other people who are involved are not from BC, they're from Alberta. So they like to put questions in about their hockey team. So in the textbook it's about the Calgary Flames, but you know, they kind of suck anyway. So I changed it to make one about the Canucks. So if you're trying to match this to the textbook, it doesn't match exactly. It's a Canucks one, but the method is the same. Okay. There's one more equation here. Notice that this is 2 steps involving brackets. Process is going to be exactly the same. Okay. We're going to do this last one, and then you can work on getting those show you know questions done. Okay. So last thing here. You should know that some of the problems we're going to solve, you can write equations that involve brackets. You have this garden here. It's 4 meters on one side, but it's some unknown length here, s plus 2. And it talks about the area of the thing being 20. How do you find the area of something? Because even though it's a 4-step process, we can do a bunch of scribbling first. Step 0 could be scribble some stuff down until we understand the problem. How do you find the area of something, of a rectangle? Length times width, right? If I call this the length, even though it looks shorter, How would I, so I'm going to highlight that blue to say it's that blue thing. And then the area over here, the area is 20, so I'm going to put 20 on this side. What's the width of the thing here? What's the width? How do you write an expression for this if we don't know how long it is? Well, however long the S is here, we don't know, but we can still work with it. That's the key with algebra here, is you can put something in here and say, I don't know how long the width is, but it's S plus 2, right? Here you're saying S plus 2, you're saying however long S is, we're adding 2 to it. We're saying this 4 times that gives me this thing, okay? This whole thing, let's get rid of some of the highlighting here. S plus 2. And let's highlight this whole thing the same way so you can see. That entire length is S plus 2. You're still just saying length times width. It's just that the width is an expression instead of a number. It's not even just a variable, it's an expression. It's two things added together. That's an equation you can solve. S is length of the shed. Okay? The equation is 4 times S plus 2 equals 20. That S has problems. You should know how to solve this kind of equation. It's the last one you did. How do you solve that kind of equation? You have two choices here for solving that equation. I'm going to do the two ways here, real quick. What are the two ways? Yeah, absolutely. Distribution or dividing first, inverse, ops. If you're doing it by distribution, you're multiplying this out like that and saying 4s plus, what would the other number be? Wouldn't be 2 anymore. It'd be 8, right? You'd have 4s plus 8. And then you solve it the way you would have done before, right? Minus 8, minus 8. 4s. Again, you should copy this down so you got something to look back on, right? 4s is 12. Take both sides and now divide by 4. At some point you're going to have to divide by 4 one way or the other. S is 3. I know you could have figured that out just by looking at the picture. Again, the process. You're learning the process, not just finding the answer. If you're doing it by inverse operations, you divide first, right? If you have 4s plus 2 equals 20, your first step is to say divide by 4. That cancels out. You just have s plus 2 is 5. And then you can subtract 2. And you get s is 3. Either way you do it, the shed is 3 meters long. Okay? You could check your answer to make sure it works. If you want to step 5 again. If this is 3, 3 plus 2 is 5. 5 times 4 is 20. It works, right? Right now what you need to do is you need to do the other two examples, other two parts of the first example, and then the show you know questions. Okay? The show you know questions along the way here. I gave you this kind of scaffolding to help you with the 4 steps. Okay, so you have about, what do you have here? Let's count how many things you have here. You have the other 2 of these, and you have the show you know for each one. So I believe that makes 5 right now. You have lots of time to do that. Once you're done that, you can get going on the assignment for this, okay?